Nuclear power plants put clean, pollution-free power on the grid, with no greenhouse gas emissions, and are generally considered to be one of the cleanest forms of energy production. But they're also one of the safest, with the lowest death rate of any energy source per terawatt hour of energy production, even surpassing wind and solar. But when a nuclear accident does occur, it can be catastrophic. A realization that became all too clear to Americans in 1979 when a partial meltdown at the 3 Mile Island nuclear power plant caused the worst nuclear disaster in American history. In this presentation, we will look at the 3 Mile Island nuclear accident, the short-term radiological exposure levels, the long-term radiological health consequences, the complexities of measuring the health impacts. We'll take a specific look at thyroid cancer and the effects on young children. And finally, we'll look at how this event has changed the trajectory of nuclear energy. The 3 Mile Island nuclear power plant is located on a sandbar in Pennsylvania's Susquehanna River, just 10 miles outside of Harrisburg. On March 28, 1979, a combination of several operator and equipment errors resulted in the nuclear core overheating to 4,000 degrees, just 1,000 degrees short of total meltdown. This would set off a cascade of effects that ultimately resulted in an estimated 22 million curies of noble gas, mainly xenon, krypton, and trace amounts of iodine, being released into the surrounding environment. Exposure models were created, taking into account wind patterns and topography, to calculate the relative exposure levels of ionizing radiation to the surrounding communities. Those found to be most affected were residents living within a 5-mile radius of the power plant, who were exposed to low levels of radiation over a 10-day latency period. The map is divided into quadrants based on level of exposure. The highest exposed group was estimated to be exposed to about 40 millirem, which is less than the dose of a CT scan. The mid-range group was exposed to about 24.6 millirem, the equivalent of 2 chest x-rays, and the remaining low exposure group saw about 10 millirem, roughly the equivalent of an international flight. Based on these readings, the Nuclear Regulatory Commission predicted the effects on the health of the local residents be negligible at most. But there is some uncertainty surrounding whether the reported exposure levels are accurate for several reasons. First, the ability to measure the radiation released was limited by a small number of radiation monitors at the plant, and none in the surrounding areas. Following the accident, environmental radiation levels exceeded the maximum capacity of radiation monitors available at the time. And blood levels of residents living near the plant were never analyzed in the days following the accident, which could have been helpful to substantiate exposure levels. Following the accident at 3 Mile Island, the health status of the local residents living in the surrounding communities were closely monitored. A 20-year follow-up study looked at the mortality in the 3 Mile Island cohort. The results were standardized and compared to mortality rates in similar counties within Pennsylvania. The bars represent the standardized range in other counties, and the green boxes represent the 3 Mile Island cohort. You can see that in every case, the 3 Mile Island cohort falls within the normal range for both males and females, and all causes of mortality, suggesting that the radiation exposure has not contributed to an increased risk for mortality. However, a major research limitation is that it was a relatively small population that was exposed, which makes it difficult to definitively identify a statistically significant increase in cancer. A group of particular interest are those who are children or fetuses at the time of the accident, as they are especially susceptible to ionizing radiation. This graph follows babies living near the 3 Mile Island power plant who were born in the late 1970s, who were exposed to radiation either gestationally or as young children, and compares childhood mortality within this group to state averages. As you can see, the rate of childhood mortality in the 3 Mile Island cohort has been elevated since the time of the accident. From 1979 to 2001, 120 children living within a 5-mile radius of the nuclear power plant have died of cancer before the age of 19, a rate 46% above the rest of the state of Pennsylvania. A second closely monitored health condition within this population is thyroid cancer. Based on studies from other radiation-exposed populations, it's found that people at the greatest risk are those who are young at the time of radiation exposure, who typically develop symptoms than 20 to 30 years after exposure. Again, given the relatively small size of the population, researchers have struggled to distinguish thyroid cancer caused from radiation from naturally occurring thyroid cancer. Recently developed genetic analysis revealed that radiation-exposed patients have unique tumor profiles, which can be suggestive of population-level radiation exposure. The graph to the left shows the genetic profile of naturally or sporadic occurring thyroid cancer, with the majority of cases resulting from single nucleotide point mutations, accounting for roughly 77% of all cancers, whereas only about 16% of naturally occurring thyroid cancer is the result of oncogenic gene fusion. However, in radiation-exposed groups, there's an increased prevalence in cancers caused by gene fusion, and a corresponding decrease in thyroid cancers caused by single nucleotide mutation. The graph to the right shows the tumor profiles in 3 Mile Island residents. The at-risk group are those who develop thyroid cancer 20 to 30 years after radiation exposure, the time frame for emergence of radiation-related thyroid cancer. Those who developed cancer before or after this period served as the controls. Notice how patients who developed cancer 20 to 30 years after the 3 Mile Island accident had altered tumor profiles consistent with radiation-exposed thyroid cancer. This suggests that the 3 Mile Island nuclear release may have played a role in contributing to the thyroid cancer in these specific patients.